Hey guys, this is Miss Basaraba. I wanted to do a short video with you about counting atoms. I did post a video in your classroom about counting atoms that is from YouTube, but I was going to do one based off of this sheet right here that I will be posting in your classroom as an assignment as well. This is going to be taking us back to the periodic table, which is something we weren't completely finished with, but I had decided to move on due to the fact that we had, as a whole, gone out of school, and this was not a subject that I particularly wanted to teach with all students working from home. So this top part right here is really just going to go over some definitions, and these are some things that the video should have gone over for you as well, but this will give you something that you can reflect back to as you work throughout these assignments. Do understand that this is going to be something that we build on. We're going to currently learn how to count atoms in a compound, and then we will be moving into balancing chemical equations. So it's really important that you understand this part right here. So starting at number 1, it just explains to you that the symbol of an element represents one of that element. So it's going into that Ba is an element symbol, and it's the element symbol for barium. Now, something that it did go over with you in the video, and I'm just going to, kind of express that real quick right here, is that when you're looking at a compound, like say, for instance, let's look at this compound right here, how you're able to identify what your separate elements are in a compound is if you have an uppercase followed by a lowercase, they're going to stay together, and that would be calcium. If you have an uppercase and then there's another uppercase directly following it, those are two separate elements. So this is phosphorus and this is oxygen. So those are the elements that would make up this compound is calcium, phosphorus, and oxygen. So I just wanted to clarify that real quick. So a subscript is a number at the lower right corner behind the symbol of an element. If there is more than one atom of the element, then the subscript is used to indicate the number of atoms. So for this one right here, you have chlorine, and it has a subscript of 2. So that is going to tell you how many chlorine molecules or atoms there would be in a compound. If there is no subscript, it's always an understood 1, because in order for it to be present in that compound, there has to be one of them. So a subscript outside a bracket multiplies all of the elements inside the bracket. So what this is referring to right here is you've got parentheses. And you guys should be familiar as far as with math about following parentheses rules. And remember, you always want to do what's in parentheses first, because there is going to come a point in time, we're going to talk about coefficients, and you would want to take care of what's in parentheses before doing what's with a coefficient. So when you have an exterior subscript, you're going to multiply it by interior subscripts. So, for example, with these right here, well, let me do this first. So you would take this 2 and you would multiply it by that phosphorus, and I should have made that a smaller stroke right there. And then you would also take that 2 and you would multiply it by that 4, because anything that's within the parentheses, you're going to multiply that 2 by it. So you'll go, for the phosphorus, you'll go 2 times 1 because there's no subscript, which means it's an understood 1. And for the oxygen, you'll go 2 times 4, which will make it 8. So what we're going to do is we're going to go ahead and I'm going to fill in what would be our atom count for each of these elements. So for calcium, it has a subscript of 3. So that 3 tells you how many atoms of calcium you have. So I'm going to put a 3 right there. And then I'm going to go down to phosphorus. And for phosphorus, we had to go 2, the exterior subscript, times 1, the understood interior subscript of phosphorus. So 2 times 1 is 2. And then for our oxygen, we would go exterior subscript 2 times interior subscript 4. So 2 times 4 is 8. So that would be how many atoms that molecule had. And if it wanted a total count, you could go 2 plus 8 is 10 plus 3 is 13. So there are 13 total atoms in that compound right there. So the other thing that it goes through here is talking about what a coefficient is. A coefficient is a number written in front of an entire chemical formula, and it indicates the number of atoms of that element or number of molecules. So for this right here, you just have a coefficient of 3 in front of carbon. So you don't have a big molecule like this one right here. So, but what happens when you put a coefficient is with a coefficient, you're always going to go coefficient my C ended up getting lost. You will say coefficient, I'm trying to get this all the way back down to the end, will multiply by subscripts. Okay, so it's always coefficient multiplied by subscripts is what will happen when you have coefficients. So for this one is you've got 3, and then your subscript for the carbon, since there's not 1 there, it's an understood 1. So 3 times 1, you would have a total of 3 atoms there. For this, I'm going to go ahead and type what the elements are first. So we have Na, then we have S for sulfur, and we have O for oxygen. And then we would need to do our counts on those. So for the Na, for that one, what we would have to do is we're going to have to go coefficient times subscript. Well, for Na sodium, there's no subscript present, so it's an understood 1. So you would say 2 times 1 is 2. For your sulfur, again, there's no subscript there, so it's an understood 1. So 2 times 1 is going to end up, that's going to be a 1 as well. So you would say 2 times 1 is 2. Then next we've got our oxygen. And for this one, we've got a 2, and it does have a subscript of 4. So we go coefficient times subscript. So 2 times 4 is going to be 8. So if you counted all the atoms of that compound, you would say 8 plus 2 is 10, plus 2 more is 12. So you would have a total of 12 atoms in that molecule. So then it's defining a subscript, even though we've already talked about those. A subscript is a number written after an atom in a formula and indicates the number of atoms of the kind in the molecule. So here's an example. It's just saying H2SO4. The subscript for hydrogen is 2. Well, the subscript for oxygen is, you just look directly behind it, and that would be a 4. That's what its subscript would be. So for these right here, it's going to have us go through the process of trying to identify how many molecules there are and how many atoms there are of each element. So when it's asking you how many molecules of H2O there are, what you're going to do is look directly at your coefficient. So the coefficient is going to tell you what that number is going to be. So you're going to have 2 molecules of H2O. So now what you're going to have to do in order to find out how many there are of each element, you're going to have to go coefficient times subscript. So hydrogen has a subscript of 2. So you would say coefficient 2 multiplied by subscript 2. And so for hydrogen, you would have 4. But for oxygen, there is no subscript, so that's an understood 1. So you would say 2 times 1, so oxygen would have 2. So you would have a total of 8 atoms in that molecule. So for this one right here, it wants to know molecules of this right here, and you're just looking at your coefficient. So you're just going to have 3. Then it wants you to go into each specific element and how many there are of it. So 3 times 2 is 6 for sodium. For sulfur, it's an understood 1. There's no subscript following the sulfur, so 3 times 1 is 3. For the oxygen, there is a 4 subscript, so you go 3 times 4 is 12. So that would be all of your total atoms for that. So you would have 21 total atoms in that compound. Okay, for this one right here, you're going to have parentheses and you have a coefficient. My suggestion for this is what I do, especially when we get into balancing equations and stuff, is I go ahead and write above these elements what they would be multiplied by the exterior subscript, so that when I come across and I multiply with my coefficient, I've already got that part done. Because remember, we always do what's in parentheses first. So I have an exterior subscript of 2, and my nitrogen has an understood 1. So that means that this nitrogen right here, right now, is a 2. So I'm just going to put a 2 there. And I know that's really messy, but I'm trying to do with this drawing tool. And then for my oxygen, I would go exterior subscript times interior subscript. So 2 times 3 is 6. So that's just how many there are right there, okay? Because that parentheses only applies to the elements that are inside of it. So it has nothing to do with the PB, which is lead. But this coefficient of 4 right here applies to all of these. And remember, we have to go coefficient times subscript. So what's going to happen is we need to first right here is we need to say how many molecules we have of this compound, and that's the coefficient. So there's 4. For lead, how many total that we have? Well, we have an understood subscript of 1. There's not a number that's there, so 4 times 1 is 4. But when we get to nitrogen, we're going to have to use that number that I got from, say, an exterior subscript times interior subscript. So we're going to go 4 times this 2 right here. So 4 times 2 is 8. And then for the oxygen, we're going to go 4 times 6 is 24. So that was a lot, but I put that number up there so that I remembered to multiply this 4 times the 6 and didn't make the mistake of going 4 times 3, because I had to multiply that 3 by that exterior subscript. Sorry. So that's how to do that one. So now going into this right here, I'm going to work a few more of these, and then I'm just probably going to do like 2 of these, and then I'm just going to end this video at this point in time. So right here, we're going to name the type of atoms we have, and you can just put the element symbols. You don't have to type out what they actually are. So you would have K, which is potassium, and then you're going to have C, which is carbon, and then you're going to have O, which is oxygen. And then out here on this side, we're just going to put how many there are of each. So we don't have a coefficient, so we're just going to be looking at subscripts, and there's no parentheses. So you just look directly behind each of the element for its subscript to know how many total there are. So for the potassium, there's a subscript of 2, so I'm going to put a 2. For the carbon, there's not a subscript there, so it's an understood 1. And then for the oxygen, there is a subscript of 3, so there's going to be 3 oxygens. And then it wants to know the total amount, so you could say 3 plus 1 is 4 plus 2 more is 6. So you have a total of 6 atoms in that compound. So for this next one, listing out what our elements are. So we have Ba, which is barium. And we have P, which is phosphorus. That needs to be capital. And then we have O, which is oxygen. Okay? So then we have an exterior subscript right here. So remember, for these, you will go exterior subscript times interior subscript. And if you want to write those on top of that, you could. So for example, you would end up going 2 times 1 for the phosphorus, and that would mean that you would have 2 of those right there. And then the oxygen would be 2 times 4, which would be 8. Okay. So when we go and fill out this side over here for the barium, we do have a subscript that follows directly behind it. So we're going to use that subscript. So it has 3. For the phosphorus, it was exterior subscript times interior subscript. So 2 times 1 gave us 2, which I had on top there. And then for the oxygen, we had to also go 2 times. We had to go the exterior subscript times the interior. So 2 times 4 is 8. And if we add all those atoms together, we would say 8 plus 2 is 10, plus 3 is 13. So we have a total of 13 atoms in that. So this assignment is going to get posted for you guys to do. So, of course, I've done the majority of them for you, but you should be able to complete the rest of this in order to be able to get this turned into me. And I will be posting a few other practice sheets to give you a little more practice prior to us jumping into balancing chemical equations. If you have any questions or problems, just email me or send me a PLP message, and I'd be glad to add an additional video or to schedule a Google Meet with you. Have a great day.